I need to record it.
Wait, still loading.
I guess it is about light.
Uh, Light and like the reflection, refraction, and diffraction, I think.
Oh, okay, I see.
Index of refraction
Okay,
and reflection.
okay, okay. So the point, so I can make a summary like your topic is about light and its properties. Okay, so today I have make a note for you. Okay, let me share my screen. Okay, here. Okay, light and wave and light properties. Okay. Actually, today I want our class to be not a lecture, not a lecture. Wait. Okay, a discussion about wave and light, but also here I have a tutorial for you about wave. Why I go back for a wave because wave is the fundamental of the light. Basically,
Okay.
if you understand the physics of wave, like the amplitude, how to calculate the velocity of the wave, how to calculate the wave number, and etc., you will be able to understand the characteristic of light. Because basically, for your grade, basically we talk light as a wave. Okay, so I think okay, let's have a review, have a little bit review about wave. Okay, okay, here. 2 weeks ago, we have talked about wave, and we have talked and we agree like, wait, why it is bright? Okay, now it is right. Okay, so wave basically is a energy transfer. Okay, I will make a note here. Wave is energy transfer. Okay, and then for wave, we the energy transfer in the wave is happening without the moving of the physical medium itself. So it is different. Like you push, let's say, a box, or you lift a box. If you push or you lift a box, you can visually see like the matter or the physical things is moving. But in a wave, we cannot see. We sometimes maybe we cannot see, sometimes we cannot hear, or
Sir,
sometimes yes.
can I go for a while? I need to do something.
Oh, okay, yes, no problem. Just tell me if you go. Okay, no problem. But you can still hear me, right? Okay, no problem. Just relax and make you feel better. Okay. If you are okay, I will continue, and maybe for today, we will just a little bit talk about the theory, and then I will like make a disc. I will discuss about the tutorial about the wave. Okay. Then because this is recorded, so maybe you can see it later. Okay. Wait, I need to reshare again. Wait, here. Okay. Let's continue. So, okay, we have just talked like a wave is an energy transfer, and then in the trial class we already talked like wave can uh, can transfer, like wave can move in a different medium. Like if the wave need a medium to move, we call it as mechanical wave. This one. Okay, and then if the wave doesn't need the medium to move, so that we call it electromagnetic wave here. So electromagnetic wave basically is a light. Okay, light is an example of electromagnetic wave. Also, in terms of the shape or trajectory, we have two kinds of wave. The first one is transversal wave. Okay, basically a transversal wave is something like a rope. Like if you move a rope like up and down, up and down. So we call it transversal wave. Also, we have longitudinal wave. Basically, longitudinal wave is something like spring. So if you compress the spring and then later it will release like a certain longer, certain longer. So we call that wave as longitudinal wave. Okay, this is the illustration for the transversal and longitudinal wave. Okay, let's move. So last week we already have talked about characteristic of wave. Basically, we need to understand this characteristic of wave not only for this wave, not only for mechanical wave, but okay, you will also use this to light. Okay, so in the light, you will also use the characteristic of wave, but there is a little bit different, but just a little bit. The concept, the fundamental is still same. So we have amplitude. Okay, the amplitude is the maximum distance from the rest of the position to a peak. Okay, here in the illustration, you can see like this is the amplitude. This is the rest line. Usually, rest line is like a zero line. Okay, so this is the amplitude. And then we also have frequency and period. And frequency and period is correlated with this equation. So basically, frequency is 1 over t. So if you know frequency of the wave, you will also can find the period of the wave. And then we also have wavelength and velocity. Basically, wavelength and velocity are correlated using this equation. Wait, V equals to, mm, wait, okay, lambda divided by time. Or you can say it is lambda divided by period. Or you can say lambda times frequency. Why we can use the frequency? Because uh, you have already say here like frequency is 1 over lambda. Or if you want to use the triangle, we also can use this one. Okay, usually people use this. Wait. Mm, okay. Phi. Wait. Let's draw the triangle first. Okay. Phi lambda f. Or you also can use wait. Lambda phi t. Okay, so it depends on you, but usually I just remember this one, and then if you know the period, you just need to remember this formula. So instead of you remember three formula, you can remember just two formula. Okay, with the black circle. Okay, so this is okay. Oh, here I forgot to explain the graph, the illustration. Okay, we have like one. Wait, let me uh let me arrange the words. Okay, in the wave, we have word like one wave. Okay, one cycle. Okay, one cycle. One cycle in the transversal wave. Okay, this is transversal wave. Okay, one cycle in the transversal wave is defined as one crest and one true. Okay, so okay, for this time, I hope you still I hope you still there and you can follow me. Okay, let's say you are in this position. Okay, in the blue dots, and then if you need to have one cycle of the wave, that means you travel through one crest and one through, one hills and one valley. Okay, but you can also how if I start in the top of the hills here with the yellow dots. You can see like this is something like you shift like here. Let's say we have a box here. Okay, the box is one cycle. If you start from from the top, from the peak of the hills, that means it is something like you shift the box so to here. So you need to travel from one hill, not half hill, until this one. Okay, this one also one cycle, one cycle, one cycle. Okay, so that is the definition of one cycle. So the one cycle is not you can start from the top of the hills, either from the rest line. It is same, but you need to fill the one hills and one uh, volley. Okay, so that's the definition of one cycle in the transversal wave. Okay, once again in the transversal wave. Okay, and then okay, I think it is better for us to finish the theory first. Okay, let's continue to the light. Okay, basically, what is light? Okay, light is electromagnetic wave that is visible. Okay, here. You need to make a note like it is visible. Why? Because electromagnetic wave is not all visible. Light is just a little bit part of electromagnetic wave that we can see and we can feel it. And then light travels with a velocity around 3 times 10 power 8 meters per second in vacuum. Okay, once again, in vacuum. I hope when you see my notes again, pay attention to the words or to the sentences that I highlighted with the red line, because usually your teacher will ask this question in your exam. Okay, light travels with velocity around 3 times 10 power 8 meters per second, and light can travel in vacuum conditions. Okay, this velocity in vacuum condition means this velocity is a velocity of light in vacuum conditions. Why we need in vacuum condition? Because if the travels, if if the light travels not in the vacuum conditions, the light will have different speed. Okay, let's say light. Okay, wait, where? Okay, here. Light in. Okay, let's say I have one in vacuum and the other one is in water. The speed of light in vacuum and water is different. I can let the speed in vacuum is higher and the speed of light in water is lower. Okay. So, so let's say because under 6 because you want reschedule the time. Okay, no problem. We can finish for the 6. Okay. So the speed of light in vacuum can be is higher than than the speed of light in water. Why? Because the water add like something like it is something like a wall. So it is something like if you move your body in the air and in the water, you will feel like you will hardly move your body in the water. If you ever swim, you will feel like you need to move. You need to make more energy. You need to have energy to move your body in the water. This is something same with the light. So that's why the speed of light in vacuum is higher than the speed of light in water and the air. Okay, middle. Okay. Okay. Also, there's some important properties of the light. Okay. There is a lot of properties in the light. Okay. You will also I will spoil you, like you will learn light until you are in the university or maybe higher. Okay, but for your grade, you will also learn about this one. Okay, speed of light, and then reflection and refraction. Okay, okay, and here electromagnetic spectrum. Okay, so here is the electromagnetic spectrum. There is a like I have told you before, we have a lot of electromagnetic spectrum, and you can see here light is only a little bit part of it. So there's a lot of type of the electromagnetic radiation, like if you know the microwaves, if you know like the sunglasses that can turn to black when you use it in in the afternoon under the sunlight, it it use the properties of light. Okay, and then there is also light matter interaction. There is refraction and reflection. Okay, also absorption, transmission, and scattering. But we can mm, We can skip for this one. Skip. Okay, because this is a little bit harder. Okay, but for this one, you need to make attention because I think this is the basic for your topics. Reflection and reflection. Okay, okay, you can see it later, but the point is reflection. The point of reflection is when the lights come to the different mediums, let's say to the what from air to the water, the beams of light will bend. So normally it will have the different angle, sorry, the same angle, but because the travel of the different mediums, it has different angle like theta 1 and theta 2, and then from this different angle we can find the index of refraction. Okay, the index of refraction basically is like the index, like the density of a matter. So if a matter is denser, is more dense, or yes, is more dense, then the light will hardly move through the matters. And then in the reflection here, it is something like a mirror. So when it is something like a mirror. So when you see yourself in the mirror, you will find that uh, you can see your mirror of yourself. It is because the phenomenon of reflection. Okay, so I think we can stop for today, and we can continue for the 30 minutes. Okay, I will discuss with your mom for the reschedule for this for our class. Okay, do you have any questions? No. Okay, so I hope you are getting better, and then do not forget to take a rest. Okay, see you. Bye bye. Thank you very much for today. Have a nice day.